I'm David Broom, Commercial Director of Kensa Contracting. We're the suppliers of the ground source heat pump system that's gone into your new home to provide all the space heating and domestic hot water required. Providing heating and hot water to our homes currently contributes around 20% of carbon emissions in the UK, primarily through burning gas. If we're going to meet our 2050 targets for reducing carbon to net zero, then this has to change. This is why the government has set the introduction of heat pumps and phasing out of gas boilers an important part of our transition to net zero. Ground source heat pump system is made up of a network of pipes buried deep underground. These pipes then connected back to the heat pump in your home. The heat pump pushes fluid through the ground array and picks up a small amount of energy as it goes. When it gets back to the heat pump compresses it, squeezes it and upgrades it to useful heat to use within your building. It's used to provide heat to your radiators and heat the hot water for your taps and showers. The reason that heat pumps are great is that for every kilowatt of electricity you put in to run them, you get 3 to 4 kilowatts of energy delivered into the building to provide your heat and your hot water. Because heat pumps are more efficient at lower temperatures, the radiators have been designed to be larger to provide the amount of heat that the building requires. Running the radiators at 45 degrees means that they're still hot to the touch, you can still feel the warmth, but you can leave your hand on the radiator compared to a gas boiler system where you run the radiators at more like 70 degrees and you can only leave your hand on the surface for a couple of seconds before it comes too hot. This means that it's safer for children, removing a scald risk, and also it makes for a more comfortable environment as a low, steady feed of heat into the building rather than high, intense bursts of heat into the radiators. So why is the heat pump a good thing? Well, primarily it's because it's a much more environmentally friendly way of heating your home. Right now, we're looking at carbon savings of around 80% compared to a conventional gas system. Over the coming years, as our electricity is increasingly produced from renewable sources such as solar and wind, you will have a zero carbon heating system for your home without having to make any further changes. As there's no combustion in the heat pump, there are zero local emissions, which contributes to better air quality, and there's also no requirement for annual gas safety inspections.
Hi, I'm Darren Veal, Manager of the Installer Development Team here at Kensa. So initially, if you'd like to put your heating on, you need to turn your programmer on and then adjust your room thermostat up until you hear a click. An orange light will then appear on the front of the heat pump, indicating that this is in heating mode. So this is a conventional radiator, just like you would get on any gas boiler system, and this is what we call a thermostatic radiator valve. To allow heat to flow into this radiator, we'll need to turn this thermostatic radiator valve to somewhere within the number range of 1 to 6. If you'd like to turn the temperature down going into this radiator, you can simply adjust it down, reducing the number. You can also put this onto what we call a frost setting, which will just provide a little bit of background heat should you go away on holiday. You've got a further setting down at 0 will close the heat going into the radiator off completely. This is your hot water cylinder, and this provides or stores enough hot water for your showers and baths. Here is your Kensa Shoebox heat pump. This is the pipework that comes in from the ground boreholes, and this is the flow and return to your heating system and hot water cylinder. Okay, this is the front display of your Kensa heat pump. The green light is your power light, indicating we've got power to the heat pump. If there's an orange light on with the sun symbol there, that indicates the heat pump's in heating mode. If there's a white light above the tap symbol, that indicates we're in hot water mode. And if there's a red light above the warning triangle there, it means we're in error mode. If the red error light comes on above the warning triangle on the heat pump, first thing you need to do is check that pressure gauge. Make sure that we have got at least 2 bar pressure. At the moment, that is currently set at 3 bar. So 2 bar minimum down at there, that point there. If failing that, we haven't got 2 bar in there, we would need to top up our ground side, which would involve opening this lever valve, quarter turn, and then the one up here, which would add water into the system and pressure. Really important to make sure we shut those both back off. Secondly, go up and check the pressure gauge up in the airing cupboard on the heating system. If that black needle drops lower than the red needle, you may need to top the pressure up. We would do that by opening these 2 black lever valves here, which are quarter turn. I'm going to show you how to open one. Simply put that in line with the pipe, and that will allow water to flow into the system. This needle will start to increase in pressure. Okay, we need to make sure that the pressure goes back up to about 2 bar. Okay, This is the other valve. If I open this now, you'll hear water start to go into the system. Just make sure that you turn that one off and that one off. When we've checked the pressure is at 2 bar, you can then go and have a look at your heat pump and it should have cleared the error message. If you find that you're topping this pressure gauge up more than 3 times a year, it might be that you need to call Kensa. If both pressure gauges are on or above 2 bar and you still have a red warning light, call Kensa.
The heat pump is controlled through a conventional time clock and thermostat arrangement. You can choose to have the heating on constant and use the thermostat to meet the comfort requirements within your home, or you can set the time clock to meet the time periods when you expect to be at home. The heat pump provides your hot water through a conventional domestic hot water cylinder. This provides mains pressure hot water at your tap. Typically, the heat pump is set up to reheat the cylinder once a day to have enough stored water for the next day's use. If you are using a lot more hot water, you can simply program it to reheat more than once a day. We expect the heat pump to have an efficiency of around 300%. This compares to around 90% from a gas boiler system. Currently, electricity is roughly 3 times the cost of gas, which means that the cost of heat delivered to your home is around the same as the cost of a mains gas system. Over time, we expect the cost of gas to increase faster than the cost of electricity to encourage more people to transition away from the higher carbon fuel and towards heat pumps. Thanks to the ground source heat pump's efficiency, for every 1 pence per kilowatt increase in the cost of electricity, the cost of heat only actually goes up by 0.3 pence. Energy security is also a concern for many people right now, but 3/4 of your energy is coming from the ground beneath your feet, and no one can take that away, and is set to be much more certain than the supply of gas. With the heat pump in your home, you're free to choose whichever electricity supplier you want, and we'd encourage you to regularly shop around for the lowest cost electricity available, as this will also help you achieve the lowest cost for heat.
The heat pump itself requires no maintenance. We recommend that you get an annual check on your heating system and your hot water cylinder. The system check can be carried out by any qualified heating engineer. As the homeowner, you are responsible for the maintenance of your heat pump system, just as you would be with a traditional gas boiler. The heat pump comes with a 5-year warranty. If your hot water or heating system fails after your 5-year warranty, call Kensa and we'll advise you how to fix it or recommend a qualified engineer. The borehole and pipework that's within your boundary is maintained and owned by the development management company. If you have a garden, you can construct a patio or decking anywhere in that garden. If you wish to go deeper than 300 mil, you will need to check your conveyancing plan. On your conveyancing plan, it will show you where those pipes are, and they're buried typically to a depth of about 1 metre. Either side of that, you will need to leave 1 metre space before digging anywhere deeper. You can build conservatories and extensions. You will need to get planning consent from the council. You may also need to get permission from the development management company. We ask that you check with them.
If you're interested to learn more about ground source heat pumps, please see our website.